Hi guys, we have here a Berkeley Maths Tournament question. This is an interesting one because this is just a limit of a function concept. So what we have to do is to just either we differentiate, we can use a differentiation approach, or we can use a quadratic approach. For the differentiation, you need to just differentiate this and equate it to 0, the turning point, and so on like that. Perhaps I will have another video for that, but I have this video is for the quadratic approach. Now all we need to do is to make this a quadratic equation. So first we will clear the exponent n here. So in order to clear the exponent n is to take the reciprocal of n, which is 1 on n to both sides. So this means that we multiply here by 1 on n, and the same thing here too by 1 on n. So we'll be having x plus n on x equals 20, oh sorry, not 20, 2 exponent 20 exponent 1 on n. Then we linearize the whole expression, the whole equation, by multiplying through by the LCM, which is x. So the first term multiplied by x, which will be x squared, plus the second term multiplied by x, which will be n, equals the last term on the right hand side multiplied by x, which will be 2 exponent 20 all exponent 1 on x, 1 on n, then x. We bring all the x's together, so we have this implies x squared minus 2 exponent 20 1 on n x plus n equals 0. We are still maintaining this value and this value, but this we're taking the inverse, so it comes to this side. Now the next thing we do is to apply the discriminant, because now we have the zero quadratic equation from which we determine the discriminant, and we know that for real roots, okay, the discriminant b squared minus 4ac should be greater or equal to 0. Okay, it should be greater than 0, all right, but if it's equal to 0, it's still it's a real root. Okay, so greater or equal to 0, that's fine. Now we can simplify this, so mostly whether you put the square root, you don't put the square root, it's the same thing, because you square both sides, then you clear the square root, the 0 is still the same, 0 squared is 0. So we have this implies that b squared minus 4ac greater or equals to 0. Okay, so now by comparison we know that the b is the coefficient of x here, so this is the b from negative 2 exponent 20, so we have put in bracket negative 2 exponent 20. Okay, so we can multiply. Okay, so we have 20 on n, then we bring the square, minus 4 times a, the a is 1, coefficient of x squared, then the c, which is n, positive n, greater or equal to 0. We solve this, simplifying this, we have this implies that this is a square, opening the bracket, this is a square here, and opening this, the bracket, this negative will become positive, so we have this also affect this, so you get 2 exponent 40 on n. Index x, okay, indices will multiply each other, so you get 2 times 20, which is 40 on n, minus this will be 4n greater or equal to 0. We can better write this one in the form 2 exponent 40 on n greater or equals to 4n. In fact, we have this, and now the inequality is quite complicated, okay, because the exponent of here the variable is an exponent, and here the variable is just a base, so that makes it a little bit difficult to solve. Not too difficult. So what you have to do is you can either use an algebraic manipulation of this, okay, because you have 4n here, this n, so you can try to manipulate the values here so that they become the same, but I would not use that. So what I want to use is another approach. We use a Lambert W function, okay, to solve this. So for a Lambert W function, a Lambert W function is a product log, okay, the product of logs. So that is what we call the Lambert W function. So for every Lambert W function, okay, you have W of x e exponent x. It should be in this format so that you can easily solve. And when you have x e exponent x, meaning the exponent value in the coefficient of the natural value, the e, okay, when they are the same, the result is still x. So from the equation, from what we have here, so from 2 exponent 40 on n greater than or equal to 4n, our objective now is to make this here, this is the exponent, okay, we try to make this exponent having to have a coefficient that will also be equal to that, okay. So since we have x here, so we want to do the same thing. So here now, beside the 2, we have a coefficient which is 1, because 1 times any number is still 1. It's still the same number, so 1 times 2 will still be 2. Now, since the denominator here is n, the denominator of the exponent here is n. So we can make this n here a denominator of this. So we divide through by n. So we'll be having 1 on n, okay, 2 exponent 40 on n. 40 on n greater than or equal to 4. Good. Now see that here there is 40 here, okay, there is 40 here, so this but it's not 40 here, so we can multiply through by 40. When we multiply here by 40, we do the same thing to the right hand side, so we are doing some manipulation. So we have, this implies that 40 times 1 on n will be 40 on n, so we have 2, okay, exponent 40 on n. I'm putting it in brackets so that we separate from this so that we'll be able to observe well. Greater than or equals to 40 times this one as well, we're getting 160. Now the right hand side is not really a problem because that's just a constant. If we just have a constant, we just have a value, raw value, so it's not a problem. The variable should be the focus. So here and here, now they are now the same, but the problem is we do not have our e, so we have to express the 2 in terms of e. So in expressing the 2 in terms of e is what we have to do now, but we know that from the logarithm property or law, we know that but ln e exponent the ln of 2 should be equals to 2, because the natural log, this is a natural log. Okay, so the base and the base here are the same, so this will clear off, you get this. So in place of the 2 we put this there, and that will work well for us. So this implies that 40 on n, so in place of that we put e exponent ln 2, okay, then 40 on n greater or equals to 160. We don't do anything to the right answer because we've not done anything at all. We just express this one in a different way. It's just like saying 1 plus 1 equals to 2. So instead of writing 2, we write 1 plus 1. So it's the same thing. All right. So now we see that the expression now is no more the same, because we have a ln 2 here. We have 40 on n, which is 40 on n, but we now have a ln 2, but here there's no ln 2. We want to make it the same thing as what's here, x. So here there is a ln 2, so we need to introduce the ln 2 here as well. So we multiply the left hand side by ln 2 and the right hand side by ln 2. Remember, this is just an exponent, this is also an exponent, so this will multiply this, but this will not multiply the 2, it will become a coefficient. That's perfect. Okay, so we'll be having ln multiplying this, so we'll be having 40 on n ln 2. Then here as well, bracket open e. Okay, so I can start to take it out, take this one out and take this one. So we have 40 on n ln 2, okay, greater or equals to 160 ln 2. That sounds beautiful. Now comparing this to what we have here, so you see that they're the same. See here and see here, they are the same. So we take now the w function to both sides. W function to both sides, 40 on n ln 2 e for exponent 40 on n ln 2, we close, greater than or equals to w function of 160 ln 2. Okay, so this now become 40 on n ln 2 greater or equals to, now this, our normal calculator cannot solve this unless we use the Wolfram alpha calculator or Wolfram Lambert calculator. Okay, so and that's from that calculator, when you press this, you compute this, which is the product of log or log product, you'll be getting 3.4657, as you could see on the screen. Okay, 0.4657. All right, so this is it. Now from here we continue, so we simplify. Now we just have to simplify, so move on. So we'll be having 40 on n ln 2 greater than or equal to 3.4657. So we continue simplifying this. Remember, now it's just to make n the subject, so we have 40 ln n ln 2, sorry, greater or equals to 3.4657 n. We are looking for n. We divide through by the 3 points, so we have 40 ln 2 divided by 3.4657 greater or equals to n. When you compute this on your calculator, you should get 8.0000, so 8.0 greater or equals to n. So you can rewrite this word so you get n less than or equals to 8.0, which is the same thing as this. So the values of n will be, for which we get a real root, okay, should be n less than or equal to 8. So we take all the values. That will be 1, 2, 3, 4, 5, 6, 7, and 8. Adding all, we should get 36. And this is the answer. Okay, so the sum of n is 36. Thank you.